Jonathan again from Team 3647. In this HSMWorks episode, we'll be looking at using the bore function. And so how I came to start using this was recently we were machining out our new intake. This is one of the pieces of it, and I decided I wanted to try using a 1/8 inch 2-flute end mill that I had found instead of the usual center drill, since our center drill was getting kind of dull and having to drill out all of these individually on a drill press left a ton of burrs on the part as well, which needed to be cleaned out. And it turns out that the 1/8 inch end mill cuts actually quite well, and it leaves a really nice finish. So you can see this video. You can see the 1/8 inch end mill. It's a 2-flute cobalt coated one, and it's cuts very quick and smoothly. These are 3/16 inch holes. These are rivet holes. And another added benefit is that you don't have to keep on switching drill bits for different sized holes. So you see here we have these are 3/16, as I mentioned before. These are 1/4, and then these ones are 4.5 millimeter clearance holes for M4 bolts. So the bore feature, it's very similar to the drill function, except you do it with a end mill. And you're going to want to make sure to select an end mill that's significantly smaller than the hole that you're actually boring out, or else you'll just be plunging with the end mill, which isn't good for the CNC or for the end mill itself. So for these holes, these are 3/16 holes, so I'm using an 1/8 inch end mill, and I'm cutting at around 20 IPM. I was able to push it a bit faster. This was just my preliminary feed rates to make sure I didn't break the end mill. And all you want to do is you just want to select all the cylindrical faces of each of the holes, and then for your heights, you can leave your clearance. So this is the tube jig, so you can leave your clearance height, retract height, and the top height the same as the default, and then set your bottom height to be about 50 thou lower than this the bottom of the contour here. This makes it so this ensures that you cut all the way through with the end mill, so they don't leave like a little bit of material left. And then for the bore, typically the default is okay, unless you're doing a hole that's really closely sized to your end mill. This bore right here, this is just like the thread pitch of the helix that you actually cut into the hole to cut out the hole with. For linking, you can leave that alone, but for the bore, I'd say just base it off a look. If it's going like if it looks like it's going too steep, then just lower it a little, make it smaller. The smaller it is, the more circles you have to do in order to cut all the way through. I'd rather risk that than I'd rather spend more time cutting than risk breaking an end mill. And this was the first part I did the test on. I also used for these holes the 1/4 inch holes. Since the 1/8 inch is less than half the diameter, it leaves like a little thing in the middle, and then I'm going with a full width of cut, which I'd rather not do with that small with an 1/8 inch end mill, since the diameter is so small. So I opted to use our 3/16 end mill, and as you can see, it cut really nicely as well. I don't have a video of it. And then for the rest of the features right here, I just did standard 2D contour. For this side, the holes here, the bearing holes, these are 2D contours. The cutout for the motor, 2D contour, and then I bored all of these holes. So this is the 4.5 millimeter hole, and these are 3/16 with an 1/8 inch end mill. And then I used the 3/16 end mill to bore out the 1/4 inch hole, and then I used a slot. So these holes, the diameter of the hole is 3/16, so I can't use a 2D contour. It doesn't generate it properly, so you have to use a slot, the slot feature. It's pretty self-explanatory as well. you just select basically the edge of your slot, just like you would with 2D contour, and then all the settings, are the same as before. And so it basically just ramps down and cuts out the slot. These are vent holes for the 775s. Another part that I used it on, the boring feature on, so you actually have these until the drill ones, because I was planning to originally drill these out, but then I realized I could actually use the boring one. So this is also a part for our intake. So these two right here. So one of them's extra, but these are made out of 1/4-inch thick plate, and they're used to attach some surgical tubing. So basically, same thing as before. I used the boring feature, and I bored out the hole. And then for the clearing out the material, to clear out this toolpath probably isn't the most optimized, but the way I did it was just I used a 2D pocket, which is the settings. You just set your regular feed rate settings, but then you just I have it cut out the inside area here. But the issue is that it won't actually cut out this area right here around the circle, since the end mill, it's too small to reach in here while staying within these boundaries. And also, I found that the end mills will undercut a tiny bit due to like deflection and machining imperfections. So most of the time, or I think every time, you'll leave a thin little sliver of foil here, which can be very dangerous and easy to cut your hand on. And so what do I do to fix this area here and this edge here is to fix the circle. I use a 2D contour and just cut this circle, the semicircle out. It will cut a bit extra, but that's okay. And then I cut out the outside boundaries. So once I cut out the outside boundaries, there's going to be a little sliver of foil left. So what I do is I use the trace tool, and I essentially just trace these two sketches. So I drew a sketch, drew a quick sketch here, and then it traces basically, and it just follows this line based on the feed rate I give it. Here's a little video, short clip of it, if I can find it. Alright, so you can see there's a little sliver of foil left here, and that just makes sure that the machine deburrs it instead of the person, so it's safer. Oh, there was one more boring toolpath that I did, and it was for this part over here. So the boring can actually save time, save tool changes. So typically when you use the drill, when you use the center drill and the drill, that's 2 tool changes, and then you got to change again to the 316 end mill, or whatever end mill you're using. On this part right here, that we did this in the vise, you actually, for this one, I did use the 316 end mill for everything on here. So there was 0 tool changes. All I had to do was flip the part whenever it was finished with the side. So for the contours, I just did 2D contour, and then for the bores, these are 0.201 holes, and I wanted to see what would happen if I used the 316 end mill, which is very close in diameter to this. And so I set the thread pitch to be pretty small, 10th thou only, so that I wouldn't like be plunging as much as I was moving sideways with it. And I believe I have a video in here somewhere. So this actually shows a bit of the cutting the contour right here. It's an 1/8 inch 2x1.5 tube, and I actually just do single pass. It cuts very smoothly, as you can see. And what's nice about cutting contour on the tube is that your cutouts just fall straight into the tube and don't fly out it like somebody watching the CNC. So you can see boring these holes, it did cut pretty well, but the machine did shake quite a bit since it was moving side to side so quickly. If you have a sturdier CNC stand, it's probably easier, since our CNC stand is kind of janky. But Yeah, so I think from now on, we'll be at least my team will be cutting most of our holes if we can with the bore function and bore toolpath instead of using the center drill and then 316 drill and then having to drill certain holes out to larger sizes or having to drill certain holes to smaller sizes. And thank you for watching.